An agent forgets things as soon as the session ends. And so we need some sort of long term storage, which we'll call memory. And what are the kinds of things we typically store in there? We might say, we want our agent to remember my writing style and preferences. We want it to remember our social communications. We'd like it to remember how we work. So, like our workflow. We also would like it to remember ideas we have. And then there's research we've done. And this research can also be things like docs. We'd like it to have memory and not have to prompt to look it up every single time. Now, the problem with this is not all things are equal. If I ask the agent to build a website, well, the docs take priority because the code has to actually be correct. And taste might be to use this particular amount of padding. But that padding can be very specific and it could be snippets of code. These things tend to intermingle. Things like, I have this idea. And to update that, we need some way to know that idea is no longer valid so that we can delete it. A documentation page gets updated in a very different way. The update mechanism is to pull down from GitHub or rescrape the site. And so if you treat this just as one thing, all you have is just really bad retrieval. And now agents are actually surprisingly good at handling this. They can grep through, but the challenge is keeping all of this up to date and retrieving it well. Doing this pattern doesn't work as well as it should in the long run, even if at the start the agent can handle it quite well. So what do we do about this? The first thing that I tried that did not work was I said, what if I just stacked these together? And I say, I'm going to have a skill.md and maybe I say use when writing. This represents a stack of skills. And I can put my workflow steps. How do I work? My preferences, my mistakes, style choices. All of this can fit into a skill.md file that our agent can pull at any point, and I can just have stack of them. This is very similar to the idea of having a markdown code base. It just has a little bit more of a strong trigger. So there's a few problems with this. The first one is that we have this issue of what are my preferences versus reference info. So what do I mean by that? So for the writing example, and this can be applied to anything, there are things like my preference is to prefer parentheticals over colons. Not always the case. I do use colons and semicolons, but generally I prefer parentheticals. I don't know why, I just do. Reference info could be a blog post or a snippet of writing from an author that I like, and that I don't want to update. And so my preferences might change over time. This reference info is really only add or delete most of the time. And so it treats all of this the same. The agent sees the file and it will update that accordingly. The other thing is it doesn't differentiate between what I call careful versus general memory. This is something like when there's a mistake or there's a preference, lots of things can just be automatically updated. The agent can pull it. This is all great. But there are times when I do something and I put something in there very specifically. Like this is exactly how I want to work. These are the exact preferences that I've done very carefully. And every workflow that I follow, there's probably an exception where it doesn't make sense to follow, and I may deviate from it. Now, that careful memory, I would not want updated ever. And so there's a difference between I've carefully curated and thought about this style versus I haven't really thought about it. I'd like it to remember it, but it can also update that as things change. And a skill.md file generally does not, it's not easy to differentiate. It's all in this file. And you can add reference files and things inside the skill and try and prompt for that, but it's not quite the same. And so what this generally ends up being as well is then you have this explosion of information in your skills. And so the skills either aren't used or you end up with more and more skills for different types of information. And even these triggers start to get overlapping. I have a technical writing skill and I have a blog post writing skill and I have a social media writing skill. And so you end up with a skill with all these different reference files, or that's impossible to parse. You don't have this idea of what was the carefully curated stuff. Or you end up with lots of skills where the triggers are just slightly overlapping and the agent ends up triggering the wrong thing. So with this, we end up with a system extremely similar to just treating everything the same in markdown files that our agent just knows the location for. We just have a little bit of an extra trigger that doesn't help that much. And we need to treat things differently when we retrieve them. So, for example, Ben Clavier is someone that I follow. He's a friend of mine, Joe Barrow as well. These are fantastic researchers that are often putting together really great research on retrieval, which is an area that I follow, and their stuff tends to be extremely practical. And so I want to follow this because whenever a research paper is put out, they talk about it on their Twitter. And so I want to follow that so I can stay up to date with kind of the research papers that at least they find are impactful. And so I want this to be stored and I want to be able to ask my agent about it. And I want my agent to be able to search it. Like when I'm working on something, if I was working on a legal project, I would want it to find this. And I treat this as much higher quality actually than just a generic paper search because these are papers that are shared by people that I trust. And then on the other side, I might have a visual brand and identity markdown file like this. And so it's a big markdown file. And when I look at this, I see this and I say, that's pretty close to chunked. A tweet can be a chunk and I can retrieve it separately. I don't really have to worry about that too much. When I look at something like this, however, that's not what I see. I say it needs to be broken up. This could be extremely long, arbitrarily long, and it might be anything from conversations that I've had with friends to things I need to take care of for a consulting client or brand and identity guidelines for myself or anything. And so this needs to be broken up into chunks. When an agent retrieves it, I don't want to put the whole thing in generally. The vibe is important. Some of the questions or the visual design might be important when I'm building a website, but not every time I'm doing something brand related. And so we need to handle these separately. Now, one approach is to convert all the Twitter posts into a big old markdown file, or each one is a markdown file, and put that into a directory and say the agent will grab through it. That doesn't work that well in practice over time. So this leads us to split jobs. So what are all the things we want to do? I mentioned a wiki and iSkills, and I talked about what those aren't good for because I often hear people saying, maybe we can just do everything there. Now, I don't think that's the case, but I do think they have a place. And so let's talk about a few examples here. We'll start with 3. We have a wiki. And so this is like the Carpathy style thing that he shared. And we have skills. These are agent skills. And we also have agent history, agent chat logs. And so I store all of my agent chat logs. So why do I do all this stuff? Well, in my wiki, it's going to be things like taste. It's going to be things like gotchas. And the agent can mostly update these things. Generally, I want the agent, if I keep correcting it on stuff, I want it to go through and I want it to identify that. So taste, gotchas, preferences, that kind of thing tends to be in there. Now, skills often are more procedural. They capture how I like to work and my workflow. And so it ends up being do this, then that. And I'm very careful about curating this. I vibe through something with an agent, get through it, and then I ask it to create a skill, and then I go over it very carefully. And so the skills are my high touch, like I trust what's in there. And it's things like, if I ask you to write a blog post, look at all the files in the directory. If there are video files, transcribe them with Assembly AI. Then read all of the files, then create an outline, and then make a recommendation on the narrative spine of the piece. Like, how does this all put together to organize it? Don't just write it. And it gives it a little bit of context about how I organize stuff, so I don't have to tell it every time, look at this file, look at that file. My blog is organized. When I start a new folder, I put everything I need for that blog post in there before I start working on it. And I've got skills and scripts for transcribing and things like this. But inside the skill, it's largely the kind of the progressive order. It doesn't have everything about my writing style. I can pull that from the wiki. For agent chat logs, this has a lot of raw evidence of what happened. And this is useful for two reasons. One, I periodically mine this to say, are there any like recurring issues and things that I continually prompt the agent or traps I keep getting stuck in with the agent that I need to update the wiki or skills or learn from myself? And the other thing I use it for is as raw evidence. Often what I'll do is I'll say, I wrote this post, it's on code quality, go through my agent chat logs and find cases where I didn't follow this. Because what I want to know is that every piece of educational material I put out, I want to know that I actually follow my own advice. And agent chat logs is one way that, of many, that I check myself and make sure that I believe, I truly believe, not just say I believe, but I truly believe what I teach because I follow that advice myself. A few more category types. This comes down to there's different ways that I want to update something. So for example, I could have a docs page or a repo. If I'm working with React, this isn't that important, but maybe I'm working with a library by Lydon who's very actively pushing the state of the art on retrieval with ColdGrep and things. And I use that library a lot, and I want to make sure my agent has the right documentation. So I can always just tell it to go look at the documentation, or I want to type a memory that stores docs and then auto updates. And so every day, go pull down the documentation. This is very different than my preferences changing over time. This can be automated script-wise. Social feeds, I mentioned that before. I want follow X researchers. This is something that can get updated every day, and I want it to continue to update programmatically. And there's other things like blogs. Now, I don't need to update once a blog is pulled down. I don't need to continuously rescrape it, and it should always have Simon Wilson post. It should always have my posts. I think my posts are good. I reference them a lot. And so it should always have these, but once it's pulled down, it doesn't need to update over and over. And all of these get updated on different frequencies and in different ways, and just dumping them into one markdown repo that my agent's trying to update doesn't work. We need to handle a little bit differently from the data storage side, but then also that chunking and retrieval side. So let's look at a demo. So this is AgentKB. I built this as a command line for myself. You want to be careful about who your target audience is. For this, it's myself. A CLI is fine. If you have users who aren't comfortable with the command line, you wouldn't want this. Now, I don't use this directly that often, but I'd like to show you how it works. The agent typically uses this. You can see my cards. These are reviewed memory cards with Anki. I have Anki cards I can search through here as well. And so I can do a search. And this search here has things very similar to ColdGrep. So I drew a lot of inspiration there. I can filter with regex. I can do fixed string matches, boundary matches, all kinds of stuff here. I can include and exclude like Python files. I can do just a semantic search. But the idea here is I can say AgentKB search, writing style. So this will do a hybrid search over my entire memory system. And we can see this atomic writing experiment that I did. Klinkenborg and style, one sentence per line for a technical Colbert post. And that actually works extremely well. I had to make some changes to my app for this. I can also see verb first instructions, not second. So there's all kinds of stuff in here, tone and voice, and collapses it down. And it also has the full reference if it needs to go read more. And so I can scope this to the wiki. I can scope it to all kinds of different stores. I have a wiki. That wiki is broken into two parts. One is just general notes. One are authoritative sources. I can search for Anki cards. I can search for my agent chats. I can search for communications like Twitter and things like that, or I can just generally search across all. And so my agent has this memory system, and this is a key thing, is that I think of memory as a retrieval system. We're reinventing retrieval. And so how does all this get stored? All of this gets stored in an AgentKB directory locally. So we can see I have a traceability DB. So every time I do a search, it logs it so I can trace and debug and improve the system. Did it find the information that I want? We can see I have logs over like RLMs, but I also have my cards, my chats, my communications, my references, my skills. Skills are part of my memory system. And so I can see under my wiki, I have sources. And these are things like the FFmpeg docs and FastPlayed and this RLM blog post and this paper. And so these are all things that I thought was important. I also have a more general wiki, and this is organized by the agent. So this is like an agent thing where I get, my brand and what were some Go concurrency patterns I ran into, and video and writing in there as well. And all of this is stored and indexed in a SQLite database, but it's also stored in GitHub. You can see that I have the skills directory, and it's actually pretty minimal. I have ones for transcribing and YouTubing and screenshots. I don't have a ton of skills. These are really for the ones that I do all day, every day. I don't have general coding skills in here. It pulls, you saw from the wiki, like Go concurrency patterns. When I run into issues, those get put into that wiki as opposed to skills. And this is things that just really impact my workflow a lot. I also have different AgentKB repos, and so I just store them in different Git repos. And so here in my sessions, you can see I use Claude, Codex, and Pi. So all of them are stored here as a readable format. And hopefully I won't dox myself, but you can see I've got all my session information. This is make all the testimonials on the About page use a lighter color. Whatever works, but not all blah. So I guess I was working on my website. And all of these are stored and can be searched. Now the readable version strips out a lot of the output. So we can quickly use that as an index to say, oh, okay, I found the file, I can read what he was working on. Maybe I need to go to the JSON-L to get the full details of all the tool calls. And I have this for all types of data. The wiki is in my AgentKB wiki, and you can see the sources in the wiki are here. All of these get updated on different cadences. The wiki probably gets updated the least. And so GitHub is really like my database. Everything is stored in files, which could be JSON-L files, it could be JSON, it could be Markdown, and the wiki is actually the one that I use the least. It's a little bit of the place that I go to put things when I don't have a better place for them. If I have a specific structured place for a type of data that's very useful, I create something. I put it in skills. I put it in its own store like I do for chat histories. And I handle those specifically. I have it for communications for my X feeds. And so when I'm in my agent, AgentKB will be periodically searched when I'm working based on whatever prompt and trigger I gave it or hook that I set. But I can also prompt it at any point. I can say, use AgentKB to see what my brand voice and guidelines are. And it'll go ahead and run that. And what we see here is, it says there's two strong sources. The brand is practical, direct, personal, anti-hop, and grounded in real work. You're seeing my system. That's the grounded in real work. And it's going to do another pass. And so it can do additional searches and pull down what these main guidelines are for my brand. Short version sound like someone who's done the work, noticed something real, and is explaining it without performance. And so that's what I'm trying to do here. I'm trying to explain the problems that I ran into, show you how I built it, explain how I built it. So let's get back into showing how all this works. I mentioned I treat this like a retrieval problem, and so let's take a look at what I mean by that. So this is the retrieval of memories. As I mentioned, there's two parts. Largely so far what we've talked about is the storage and how do we store and chunk and why do we store them differently in different places. And now we're going to talk about how do we get them out, because just because we store them and they're accurate and they're updated doesn't mean we can access them when we need to. In general, there's some sort of query. Now, typically this is done by the agent. That's the point of the memory system. And we then have a store filter. If I'm asking about, hey, when I was working on this project, what happened? That store filter is going to be applied to agent chat histories. Or if I say, can you look at the retrieval researchers timeline and figure out what new retrieval papers have been out? It will look at the Twitter. If I say, hey, I'm writing this blog post, it might search and it might look at the wiki for previous writing mistakes. And so the first is we filter by store, which has a meaningful filter because it determines the types of things that we want to do. And it goes through a hybrid search. And this is a little bit different than what most people think about hybrid search. And so we're going to cover that in a second. And so we have query, a filtering step, a hybrid search. We then have another filtering step. And then we, of course, have our final filter, which is a top K. If I find 1,000 results, I don't want it in there. I probably just want the top 5 results. And so this is how the system works. You also have search, you have keyword, you have semantic, maybe you have re-rankers. And so you have this like Lego building blocks of lots of things. And so I think the filters are pretty clear, I hope. If not, leave a comment and ask. I'm happy to reply to questions. But I said this semantic search is different. And so let's see how it works. So this hybrid search here, this is what we're talking about here, is your standard setup where we have a keyword search, we have our semantic, and then these get fused together. Now this keyword search is fairly normal. It actually uses trigrams as well as a keyword search. But so this is fairly normal. And the semantic is what I want to talk about because it has a little bit different architecture than most people think of. They mostly think of a traditional semantic search. So what's the difference? In a traditional semantic search, or in both systems here, you have some sort of document. And so I'm going to say there was a tortoise and a hare. The hare was fast. The tortoise was slow. Okay, great. So we have 3 sentences. Now, in a traditional semantic search, what we see is 3 chunks. There was a, let's just say sentence 1. I think you get the idea. So this chunk is there was a tortoise and a hare. There's sentence 2 and sentence 3. And now maybe these are paragraphs or maybe they're something else, sections. But the idea is we've broken this into chunks. Each one of these is represented by an embedding. 1, 2, 3, whatever. Maybe it's 768 in length or something. But they're all represented by a whole bunch of numbers. We're then going to have a query. And so maybe that query is something like, who is fast? And we want to know for this query, which one matches. The way we do that is we compare. And we do this. We compare this query to all 3. And this is also represented by this single embedding. And we say which is closest, right? So that's the traditional semantic search here, which is closest. And so what are we doing instead? Instead, we're doing something called late interaction. And why is late interaction more powerful? It's because there's more computations. Let's take a look. Instead of saying, let's create 3 chunks, I'm going to create a whole bunch. In fact, basically, I'm going to create 1 for every word. And each one of these is going to be a number. So for example, I'm going to have blah, 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 and all of these are going to be their own embedding. And so each of these are their own embedding at the individual word level, to the token level, roughly a word. And so you can see already we have quite a lot more data than we had before. Instead of 3, we have 1 per word. So what happens on this side? Okay, on this side, the same thing happens. And so this turns into who is fast. And so there's 3 because there's 3 words here. And so now instead of just a single one of these, we have 3 embeddings instead of 1. And so on this side, we have more embedding. On this side, we have more embeddings. And we say, okay, so how do we see if this document is best? I'm going to take this and I'm going to do some math on it. Every single one. I won't actually draw every single one. Nobody wants to watch me do that. And so this token gets compared to every single one. And then I go to the next one and I get compared. And I'm going to post a video about quantization on this because while there's some computational shortcuts that mean we don't actually have to do it on every single one, but doing it on every single one would be the more accurate thing to do. We're just taking a shortcut for computation's sake. And so we compare them all. And really what we're doing here is we're doing a sum over the biggest match. sum over the biggest matches. And that tells us how relevant is this document to this one in particular query. And you do that for every document. And there's still chunking and things like that, and there's lots of tricks to make it faster, but the even with all that, I think it's very clear that this is quite a lot more computation than the other one above. More computation. This makes it more accurate, and I think this is one of the reasons that grep had been winning out for so long over semantic search. So grep has quite a lot of benefits to it. Semantic search has been getting better. This was traditionally just not feasible to do. Now I'm running it locally all the time on my laptop, and it just stores in a SQLite database. It doesn't replace a keyword search or a grep. It combines it. This is just one additional tool that it can do. And the combination lets the agent search when it knows an exact keyword, when it sees an import statement and knows I need to find where this library is used. Great. It can find that exactly with a keyword search. When it knows it's looking for something related to concurrency in the authentication thing somehow, it can do a semantic search, grab some stuff. That might be enough to find the exact class names, and then it can search with an exact keyword match. And so that combination is really what makes it powerful. So there's two main things I want you to take away from this. One is memory works very similar to retrieval, and there's lots of ways to retrieve. One is agentic retrieval. Skills work this way. The second is a semantic retrieval, and it's still actually agentic retrieval because the agent is calling a semantic search and it can iterate on that. There's also text searches, and they're all good in different contexts. It needs to have this retrieval layer, and different types of data needs to be chunked and retrieved in different ways. And not just chunked and retrieved, but from a human perspective and how you update and save and store changes. How much priority I put on something, how much trust do I have in this thing that is stored. If the agent inferred it based on some opinion I had in a moment, I don't put as much trust in that as something that I've thought about carefully and written a document about. And those need different levels of trust and different levels of evidence in order to change them. If this is interesting, I'd like to invite you to join my community. It's made for people who are building commercial systems, and we do deep dives and evals, and we compare systems, and all of it is based on what are the challenges that individual members are having. If that's at all interesting, you can check out the link in the description. Otherwise, go ahead and follow here. I'll continue to put out free content as well. So thanks a bunch.